Hello, my fellow YouTubers. This is Roy back again. Happy New Year's. Let's go ahead and check out the developments in the wheel. We're going to go over a couple good things tonight. This is kind of exciting, actually, real exciting. So, I was working on the PMH and I had an aha moment on the PMH. And I started grabbing the PMH, picking it up, putting it over to the wheel, and I would hold it right here, and I'd spin the wheel and just bring it closer. And I would just leave it there, just kind of feel the tension between the iron bars and the magnets. And I did it first without the coils. Then I noticed the effect and whatever, and then I put the coils on. And then I noticed that when it slowed down and stopped, that it would stop on the pole of the opposite pole of the PMH. Because the PMH is soft iron, but somehow from having the coils on them and charging the magnets and just zapping them with the battery, they became polarized. So this is the North Pole side and this is the South Pole side. And I noticed when I was holding it, if you hear the fireworks in the back, they're shooting them off in the neighborhood. Happy New Year's. When I held it with the coils on, it became different than without the coils. Like it was its own magnet, but stronger. And I would be able to. Let me see if I could just do it with this one. This one's kind of heavier than my other one, but if you hold it in front, now remember this is right there. So we put the south in front of the north, and we're going to see the wheel pull itself. Let's see, I'm moving right now. Look, the wheel's following the iron. The wheel's following the iron. Now, the wheel's following the iron over there. See it just pull itself? Now that's South Pole right there, and that's North Pole. So I started to just digging deep here and just kind of, hold on, I'm trying not to touch it. It keeps going to me and pulling me to it. So anyway, so you get the gist of some motion there, potential motion. And I'm not talking about putting power into the PMH like I did before. I'm talking about just the reaction between the PMH and the magnets. And I said, okay, hold on. Let's check this. Let's do another experiment. So you hold up the compass, say, all right, that's South Pole, that's North Pole. Now, visualize one of the magnets going by, whether it's north or south. What happens to the pole on the other side? Does it flip? And in my head, it said it would flip, because this is amazing, I think, right now. I'm going to show you guys something that's just going to start to sink in if it hasn't yet. So you got your South Pole there, and you got your North Pole here, and I happen to have a nice magnet. And the magnet right here, we're going to put a North Pole. So we're going to go ahead and remember, this is north and that's south. And we're going to come and move. What's up, Dave? Dave in the house. Now watch the compass flip. So now the pole just flipped on that left side prong right now. Now it's the North Pole, and this side right now became the South Pole. So the coils allowed this flip to happen. Now watch this. I pull away. That should, there it goes. That should, but it's following my magnet, but it should go back. I guess if I was holding it like this, it would. So let's just do this then. All right, so that's, put the magnet over there. That's South Pole, that's North Pole. All right, so we're going to go on this side. So when the magnet comes sweeping by, it changes the pole on the other side. And then it flips. And then it changes. The magnet's so strong, I got to put my finger in front of it. So you can see it. The PMH is swapping its poles like a AC generator. We're going to call it. Pretty much. Right now it's an AC generator. Thumbs up. So I realized that when the PMH, when the magnets go by the PMH, like this one here, 22 gauge wire, 1500 turns. It's got some great resistance in there. And the whole key is resistance. What's up, Miguel Angel? In the house. So you build up resistance, and that's the key here. If you want something to be, say, perpetual, you have to have like a give and a take. More than just the magnets going through, you need to have a system in there of circuitry that's going to take the other part of it and make it also act like a magnet back at the magnets, and it's going to give a give or take in that way. And I'm going to show you some cool experiments. But basically, when you turn this and it goes by this PMH, what's going on is the back EMF of the transaction between these poles flopping is creating the magnetic field. The magnetic field is swapping at the prong end in the front. I just showed you on that last experiment. And when it's flopping the opposing. So every time a magnet approaches, the opposing magnet appears on this side. Now check this out. The resistance you build in on this side now starts to act and react side by side. So now you're taking magnetic pulses into iron. The iron is causing the copper to create a magnetic field around this whole thing, like sort of like an aura on a body, but it's a shell around the PMH. And you're going to see that's south and that's north. So we're going to see it. Don't always happen, but sometimes, but mostly it does. We're going to see the north show up over here. All right, so like I said, right now it's pulling magnet to. This is not a magnet. This is remember, there's no power in this side here, but it's creating it to be a magnet when the wheel's turning. So we already had poles here, so it's polarized, and with the coils on there, it's kind of like locked, ready to go. So as soon as you get this, say in the middle, you'll see. Watch, I put it in the middle. It'll pull itself. So it pulled itself. You can see the springy effect. That's because this is like becoming a magnet when the approaching field. See, right now it's at full saturation, so nothing's going to happen here. Once you pass it, now you're stretching it. Now all of a sudden, watch. I don't know if you can hear the fireworks, but yee-haw. All right, let's go back here. So you can see there's going to be movement in the PMH. Now this is kind of acting weird because it's going up and down, but you can see just by turning the wheel, there's movement. Now let's go ahead and add some resistance. Let's put a load on this, because as soon as you put a load on it, now it's going to act a little bit more differently, okay? And I got a few different examples here that I made. Bigger capacitor with a LED. I got a smaller capacitor with 2 LEDs on it. I got one capacitor that's 200 microfarads and 50 volts, which will never hit 50 volts. And we also have just a capacitor, just an LED. And we're going to start off with just an LED. All right. Now let's go ahead, and what I'm doing is I have these coils set up to where this coil, when it has power coming in to the beginning wire, a positive power, it creates the pole that I want to come out the end. But when you wind the coils the right way, counterclockwise or clockwise, you're already creating the pole here by choice. So I wind these the way they need to be for that to be a south pole and for that to be a north pole. So now I take the beginning start of this wire and the end start or the end of this coil, and I put those together. Then I put the other two ends together. And I come out of that because what we have is an AC generator right here, or transformer, AC transformer, I guess you can call it. But the whole thing is a generator, maybe together, but more like a transformer. So we're coming out of AC and we're going into a full wave bridge rectifier, which I have somewhere here. All right, yeah, we got a file. Here we go. So the full wave bridge rectifier, if you ever made one before, they're easy. If you haven't made them, they're easy. So the two ribbons are facing each other, and then the other two ribbons are chasing them, and then they're tied together. The two ribbons face each other is DC positive. The backside to that is DC negative. And either top or bottom are both AC. It doesn't matter what it is. You're just coming out of here. So it doesn't matter on either side how you come out. What really matters is the coils are wound to always naturally create the pole of this end to be what you want it to be. You guys follow me? Put your thumbs up. Give me a shout out. Anybody out there want to shout out? Come on in. So so when we turn the wheel, this array here on the PMH is like magnet, unmagnet, magnet, unmagnet. And you can see now that it's got, the wheel's got something to pull through. So let's go ahead and, like I said, we're going to connect, let me, I guess I can do this in one hand. We're going to connect a negative to the short side of the LED. And then we're going to connect the positive to the long side of the LED, okay? Now we're going to turn the wheel, and you're going to see you got, the faster I turn, I got this thing turned away from us, by the way, too. This thing is like, I don't know how it hasn't blown up, because it makes me like I'm welding that I can't even see. All right, so you can see we're creating power. We are putting the load on. With the load on now, it's given this more resistance. So the resistance that's built in here is helping the wheel turn on its own. Even though I turned it, and it's going to stop on its own, because there's other parts of this we're going to get into on how do you make the wheel perpetual without adding power. Just by its own power, it should be able to keep turning. Whether it's turning fast or slow, I think it's based on the resistance we add to the system. You can't have too much, and it's all about windings of coils, looking exactly, knowing, doing the math and knowing what you need for resistance around the wheel. We're going to be putting another pipe in on this side, and we're going to have counter action with no power going in here other than the wheel, and we're going to first just start to get the wheel to turn on its own. So the next thing is, you see like the lights out, okay? So here we are, we made power, there's nothing stored, the energy was made, dissolved, and gone, okay? So now we're going to go ahead and move past the LED, put that over here. And let's go ahead and go to a capacitor with a light, okay? One light and a capacitor. So let's see what, when you hook these up, these electrolytic capacitors, make sure you, hey Hassan, what's up? So the positive on the, and then you see that's the negative side with the stripe on it, and then just put the negative over there. So now we have a capacitor in line with the light, and we're going to check to see if we can light the light, and then if we could stop the wheel and have a charge in the capacitor to keep the light going, all right? So this time I'm going to turn the lights out a little bit because I already know the result. All right, but you can still see good. So let's go ahead and get the light going. The light will come on bright. You know, I just spun the wheel just with my hand just a little bit. You can see strong light. You can see it's the wheel's slowing down, so the light will dimmer. Now I'll stop the wheel, and you can see we still have light. We're able to save energy right there. And right now we have resistance in the system, and we're burning energy right now. But you can see it'll run for a while. I mean, what's pretty cool is, let's go ahead and give it a nice hit, right? Look how bright that is. Wheels turning. Check this out. We're going to take a walk and go out in the dark in the back here, and we'll see how much charge goes in that capacitor. So we're burning light, but we're adding resistance to the PMH now. And now the wheel and the PMH are doing its floppy thing. So every time a pole comes present to this pole becomes the opposite pole in front of the other pole. This becomes a magnet when the wheel is facing it, and you have your own electromagnetic reaction going on between the magnets and the field coil, we'll call it, the PMH. All right, so the wheel will just stop. Let's go ahead and disconnect the power. And let's go ahead and just take a walk. And we're outside in the dark. You can see we got LED lit up. We got some storage. Hey, William. Happy New Year, everybody. Hope you guys are all safe. So here we are, LED lit. I don't know if you guys can see any stars up there, but all right. Not in the camera, I don't see them, but there's a lot up there. So LEDs lit up. We stored energy from that last wheel turn. Yeah, I know you guys don't see them in the phone, but guess what? There's tons of them up there. So the teleoptics on the phone doesn't see the stars. LED's still lit, so let's put that LED down. Let's put the lights back on. All right. So interesting. So first we started off where we had a LED. We made it go on, and when the wheel stopped turning, the power was gone, no storage, nothing, right? So then we took a capacitor with one LED, and we did it, and we were able to store power, and we were able to add the resistance to the system. So let's move on a little bit. Let's go on to two LEDs, which would burn more power with one capacitor. Now, remember, we're going to be by doing this with the two LEDs, we're adding more resistance. So bigger load, more resistance. Now let's see what happens, okay? Let's see if we can we can charge the capacitor, and let's see if we can light the LEDs by turning the wheel. And then let's see if we do have storage. Let's take a walk with it and see if it acted like one capacitor. Because here we're putting twice the resistance, twice the load into the system now. Now what's going to happen is these are become stronger magnets. These are going to be opposing a little bit more. So you're either going to see the wheel on its own take off, or you're going to see the wheel slow down. You guys ready? So here we go. Now you can see how bright the LEDs are. They are screaming bright. Wheels turning. The wheel seems like it's reacting stronger to the PMH. The table's vibrating more. So that's how I can tell the magnetic strength on that's stronger than that. You may not know that, but the table vibrates more. So now we can see the LEDs went real dim. Wheel's going slow. Stop the wheel. Do we have LEDs? Did it save? Yeah, they're on. But not like the first one. So we put too much of a load onto what we have here as array. So let's go ahead and try another example. And this one, we're going to go to a bigger capacitor with one LED. So we're going to stick with the same resistance, but we're going to now stretch out. Hey, exhibits in the house. Happy New Year. We're going to stretch out the capacitor storage plates, basically. So let's go ahead and get this thing turning. What's up, Adam, in the house? What do you mean your phone's not working? I called you a few times. Now look at this. We got bigger capacitor, more field storage. You got the LED screaming. Look at that. Look at the wheel, LED screaming. Now let's check this out. If we saved any energy. So the wheel's slowing down. You can see that the light's slowing down. So we're going to stop the wheel. Let's disconnect. And let's take a walk in the dark with this setup here. You can see the LED's got some good strength about it. So we stored energy in this capacitor. And now we're out in the dark. You can see, it looks like the moon, huh? Let's look up again, see if you guys can see any stars. Oh yeah, there's a star. That's a star right there. Can you guys see it? All right, let's see what else. Oh, just that one, huh? So this LED is lit up from stored power. That's a star right there, guys. Right there, right behind my light. That's a star there. LED still lit, stored power. Let's move on to the next experiment. This gets even better. All right, still lit. Stored power. So let's go over what we did so far. We'll backtrack. One big capacitor. Now let's move on to the next capacitor. Where is my big old chubby? Now this is a DC. Let's see what this guy is. 6,000 microfarads, 50 volts DC charge or surge. And that's about it. And let's go ahead and nice capacitor. Let's go ahead and hook it up. All right. Now remember, on all these experiments, I'm just giving the wheel one good swallow. Poof, and that's the charge we're putting in there. You can see I got a little bit more work to do with here, with a little bit more balancing, but we're pretty close. That's some damn close-ass, tight distance between those two. Let's go ahead and stop the wheel. Disconnect. Got ourselves a capacitor, but now it becomes a battery. Why? Because we got an LED on it. So here we are. Huge capacitor. Let's get past storage. So we're going to come over here and we are going to go back to Ed's magnetic current. Magnetic currents are made by concentrating, then dividing, then shifting the existent north and south pole individual magnets from one place to another. So we concentrated them in the capacitors. So when you look at the capacitors, you concentrate them. So now we're going to move on to dividing. So every time, remember this naturally is the South Pole, that side, and that side's naturally a North Pole. So when the opposing magnet is approaching, here's your North, here's your South, your poles will start to change, and the magnetic field in here will be expanding and collapsing, okay? Expanding and collapsing in the PMHs, like a heartbeat. Boosh, 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 boosh. Especially when we put the other one on this side, you're going to have every time. One thing I didn't show you yet is that in the in the in these magnets, when we talked about how the field runs, it goes straight across as first stream, as induction, okay? And then it comes out as a radiance from out from the north into the south, out from the north into the south. So that means this right here, this whole thing in the big picture is back here. It's sort of taking on the space, okay? Not as this, but as this. Because these two streams are coming out and going in. And then on the other sides of those, the same thing's happening here. So you have also coming out, going in, coming out, going in. But in the same connection, this is coming out and coming in. Then you'd have the same rotation going around. Well, that's creating the magnetic field right now in the PMH. So the PMH is reacting to the wheel, but right now, because it's only one PMH, and I haven't figured out the right resistance yet, because once the balance is a resonant balance between these, in between the, I don't have the coils on here yet. And I think that's when I'm able to balance, because I'm able to put a small DC. See, the back EMF of this creates a not only current, but it creates the magnetic field of the coils, the back EMF. So every time this son of a bitch goes by, it all of a sudden gets past where no longer is it able to react. It snaps back, and that back snap has the magnetic field pulse. And then the same thing on this side has a magnetic field pulse. So you got to think what's happening is between this magnetic field that we just talked about, your norths are coming out into your south. So we're running this way. So think about motion. So if we're running this way, and we're always running this way, we are running back this way. But in field direction, I guess the field direction, meaning that depending on if you spin this rotating clockwise or counterclockwise, I would think that you would have the pulse happening here just the opposite. So there it is going counterclock, and there it is going counterclockwise. So clockwise presents North Pole, and counterclockwise presents South Pole. So knowing that, we're getting into dividing. So let's start off from the PMH being the pulse, the heart, okay? The magnets are permanent. And with putting coils on them, we just make them stronger. So that means we can project out as a stronger field than a field itself. But that doesn't mean it has to be strong. That just means one thing, that I can make it stronger on the wheel side. I can make the permanent magnets stronger. So that means the whole system itself would be stronger, because the field magnets, the field magnet is reacting off the magnetic strength of this. So if I increase here, this will be increased magnetic field inside the PMH. So with that being said, once you get this wheel turning, you're going to have reaction, action, Action, reaction, action, reaction. Now we got to move into the center a little bit. So now we got to get the compass. And let's look at magnetic fields. Well, we know that all these magnets are isolated from the bottom inch, almost 3/4 inch thick steel flywheel with a gear ring like this on the top and bottom. So this way Ed could screw it together, tighten down on the magnets, as well as these prong ends go through the flywheel, and they're in natural holes of the flywheel, so I didn't have to make those holes, I didn't have to make these holes. So this here pulls down this upper ring, which forces down this ring, which takes the magnets and now straightens the magnets out. So we're going to be, I'm not cemented in yet, but you're going to see that I have it to where I can balance the magnets this way. It was smart. So we'll be putting nuts on here, cranking down on this. I put beautiful, thick plastic tubing. Nothing's touching the magnets. It's beautiful. This is beautiful. Nothing is touching the magnets. Same thing with these guys here. That's the way to do it. I wish I would have thought of that 100 times ago when I built this wheel. I built it for Ed before, now I'm building it for me. So this is my wheel. So here you go. So it's all protected in there. So now we're going to take the compass and let's see what happens to the top of the handle. Well, the top of the handle becomes the North Pole. I don't know why, but it is. It's the North Pole, okay? When I got into putting this wheel back together this time, and this time only the first time, out of probably a good 30 times I took the wheel apart. Different reasons, magnets, charging, yada yada, not shape, not this. And at this time only, did I look at, I got pictures of Ed's wheel when I was there. And I got reference pictures from, I can't show them now because they're on my phone, but I'll print them out and show them next time I do a video. But I have a picture of this right here. So Ed's pipe, I have a picture of where the handle is in angle, and the handle is in this angle. This is the picture I have. And I could see every bolt sticking out. There's 4 bolts on the magnets coming out, and the bolts that are coming on the top clover ring, you can see position, and you can see position also on each one of these bolts around, all 8 of these around the. So with that being said, this wheel is accurately, every bolt and every position is, the handle and everything is accurate. Maybe it doesn't even matter, but maybe it does. So this time I'm just being very, very precise on this build here. And you know what? We have right here, I have a mark here and a mark here, and then we're building a circle, a metal circle with a little finger sticking out. And that's the spark gap. You see that? When I concrete this, only the bolt's going to be sticking out. And then you're going to have this here. And so what is that representing? You know, I always said it's a spark gap, but you'd have to have high voltage electricity to jump a gap like that. I know from just my experiments that basically we're talking 1 inch is 80,000 volts. So with my NST, it's 15,000 volts, 60 milliamps, which is a lot of current. You know, I can tell what spark gaps, what they do and how they react. So this is a different spark gap. This is not a high voltage spark gap. And I only have this steel wire on here for a reason. I've been experimenting with the steel wire, and what I realized is steel wire is a pulsing wire. It's not a inductive wire. You wouldn't want to use it at all for electricity. Pretty much, But I'll tell you one thing, it's no copper. I think Ed was wrong a little bit on how he said in magnetic current that steel wire has an advantage. But I think he maybe was really talking about was the advantage was it become magnetized. But it becoming magnetized, you can't stick 12-volt battery to it. It overheats and melts the plastic. And if you pulse it, then you can get away with the temperature, because when you pulse it, you're giving it a collapse. When you have the collapse, you're collapsing the field in it. And when I take the compass up to it and run the compass on it, you know, you can see like down here, up here north, right? So where's the south show up? Look at that. South shows up at the end of the array of the neutrals. So you can see there's a polarity change in itself just on the handle. The handle is wrapped with copper. This wire will come off. I just wanted to show you guys how this gap is. It's an inductive magnetic gap. And I think that is the same presence as having a keeper bar. Now this little section becomes its own personal PMH. Before I put the keeper bar on it, it was sharing the whole array, because the bottom, this gear ring and this flywheel is a sandwich, okay, over the magnets. Look at my fingers. It creates a C. What is that C? The C is this. That's a C, okay? That C right there is a PMH. So you have the framework becoming the PMH, just like this PMH. That's why it's important that Ed talked about in magnetic current, why he can make his permanent magnet stronger by the windings that he uses. You don't see the windings in his picture, but the windings that he used was the machine, which was this one, that had windings here, which allowed the machine to be stronger. Why does it need to be stronger? Because we're talking of the whole process here on how when this bypasses the PMH, how the PMH becomes reactive to the wheel and becomes a magnet in itself and has strength built in on the resistance. And that's where the bottles are on top of the pipes, because we're going to use resistance wire. And you're asking me now, why is resistance wire important? Well, I'm not really looking to light LEDs, right? You know, I'm really not. I don't want to burn the energy. I want to use the energy. But I'm displaying right now how we just made electricity. We stored electricity in the light, and in the capacitor. We burned it in the light. But the key thing with the light is that it's a dioide. And that diode only allows one flow of traffic. And that's where we're going to get into the system here. Because with the resistance, not burning light, but creating a resistance, what we're doing is we're putting tension inside the system. So every time this thing has the wheel go by it, it's becoming like my fist, like it's getting stronger. But right now it's not. Right now it's shallow and weak, and it's only slightly reacting. And it makes the wheel right now turn even better. Look at this is crazy. You can see you know how much weight this wheel is? This weight, it's gotta be 250 pounds. At least. It's crazy heavy. And it's reacting to the PMH. There you go. Reaction between the iron and the copper. So let's talk about, now we're taking the reaction to the magnets. The magnets are creating the reaction. Now the magnets can be stronger or weaker. We'll get into that later. But now in the inside, we're moving the magnetic field in. And why are we moving the magnetic field into neutral? If you look at this, it pretty much resembles to me as an atom, to where the center, the nuclei would have a proton, it'd have a neutron, and then you'd have your so-called electron sign. Well, here in the center here, I've noticed that the compass goes to true north. This is where north is in my workshop. And soon as just like right now, just look at it. It's wanting to go there, right? There you go. It's going up. I'm pretty far from the wheel, but I get close to the wheel. Then it starts, you see it moving, probably because of the magnets. Then I put it inside and it finds its way back. So in the wheel, it's like a safe haven. For some reason, what I'm saying is the magnetic loops, the light field that's going around like a flower. It's definitely like a flower. Let's call it a flower. It's going around. It's in circles. It's evolving in itself. It's going into each other. It's coming out as a round. It's coming in as a round. Yes, like an eye of a storm, Adam. And pretty much that's happening all the time. So that's where we go to here, where we're talking about dividing right now. We already showed concentrating. So now we're talking about dividing, but and then shifting. So dividing and shifting. So basically on the shifting, that's where we're inside here, we're shifting, because here you could say we're dividing because we're switching here. Got a switching thing, so we're dividing. We showed storage, which on Ed's thing pipe he has, which has two pipes. I got another picture of Ed's wheel, and we're showing the motor block down bottom. And in the cylinder, in the back of the cylinder, there's a pipe or a metal plate, and each cylinder section is burnt. So that shows me burnt like that. Like each cylinder has a burnt like that. That's for me welding. So I'm burning that with a torch. But why would he have a plate in the back? He didn't need it for anything. And it's burnt on the inside. So now coming back to the inside. So now we're working on the inside of the wheel, and you can see that. Let's walk through the wheel, because I set the wheel up exactly like Ed's is. The only thing I'm not 100% sure, the difference between my wheel and Ed's wheel, is what pole is facing that angle, because I got this set up the same. The angle of how it's hitting the pipe, but I don't know what pole it is. I've been here many times. I've never, ever thought of this. So this could be a north, this could be a south, but I don't think it even freaking matters. So let's go ahead and walk it. So on these pipes, now remember, each one of these bolts are coming from the flywheel below. So we knew that flywheel on the top is a negative, and then it's positive there. And let's see if anything down bottom here. I don't know if we can even, no, can't even tell. So there really is no top and bottom, but it'd be more like the flywheel itself would be the bottom, and the top would have to be the handle because it extends. So if you look inside here and go to the back of the magnets, this is only going to turn for whatever side of the magnet you're on. That magnet, if it's north, south in the front, that'll be a south. If that's a north, that'll be a north. And then there's sort of a spot right here where this will just kind of, check this out. So this will, you go on this side, you got north. You go on this side, you got south. So in this area here in the middle, it kind of goes in between. It's kind of like predominantly on each side, not on both. Very interesting about these V-shaped magnets. And the same thing happens with the PMH here. That on the PMH, if this is South Pole, that's a South Pole as well, all the way up to here. And then if this is North Pole, this is North Pole on this end, all the way up to here. If you take most coils, cylinder coils, and you put an iron bar in the middle of them, and they don't wrap around and go to another coil, one end becomes one pole, the other end becomes a pole. Think about that, guys. Very important. So the tops of these, here you go. You got South Pole on that one. You got it fighting right there. You got it fighting, but a little bit more south. You got it fighting, and it's totally south. Now let's talk about this now. Now the direction of the natural stream here, the medium that Tesla talks about. Here's my North Pole, and over here's my South Pole stream. So I'm on an angle coming across here. Perpendicular, I guess, but comes across through, around here on the wheel. So streams right now are running this way. Here's your streams. They're running, magnetic streams are running that way. They're running up and down, but they're running that way. So when we take this in reference of that angle, what if we just move it over a little bit? Does the pole change? Well, let's go ahead and move the wheel a little bit and see if let's call it out. You see it just flip? Let me use my body. Let's go back here. You see that flip? So when it flipped, it got to east. As soon as it got east, it flipped. There it goes. So east is right there. So as soon as this compass and this iron pole, it shifted. And watch it, it should shift around here. Here it goes right there. So that pole changed, that bottom base changed its polarity. So you got to look and see what's going on here with the natural medium here. Because the natural medium is affecting the plate itself, which would be the C part of this. The inductive part is right here. Coming out, and there's your inductive part. That's like putting the keeper bar on. So you can see where we're taking the magnetic field, we're coming in, and we're able to say that all these risers here shift. They're connected to the clover ring. So the clover ring itself, insulated from this bar, which is insulated from the magnets, sits on its own by itself as a round ring. Round ring, remember that, guys. This one here is flopping its poles. So all of a sudden now, between this thing and this thing, there's a magnetic, hey, Tommy Tom, between here and here and the top of these magnets, there's a magnetic induction going on between these. And this is flopping between the clover and the ring. So let's go inside the wheel. Let's put the wheel back to what Ed has at Coral Castle in reference. So we're in reference to the pipe. So now let's go over to the first bolt, to South Pole. Now if I push it over to the other side, like that, you see it changed the poles. So over here, you got South Pole or North Pole, South Pole. On the keeper bar or on the gap ring, your North Pole. So you're going to have a magnetic, this is how current comes in between the neutral area here, to where you have a south is here and north is here. So the north being negative, which is the ground, comes up and down the ring with the U-shaped. Every time that this pipe handle comes around and close in proximity to the U, creates the connection, in a sense, an induction and connection, and then that gap should go off. So you'll have one. What you're going to do now is you're shifting all that magnetic energy from all the iron that's in here is going to be pushed out between this bolt and this keeper bar that comes off of here, up the handle into ground. And then you have your pipe, your coil inside of it, your two bottles up top, one resistance, one capacitance. And you also have a electrostatic collector down bottom, which inside the square down bottom be electrostatic capacitor, be two plates with a dielectric. And you'll have a dipole from the top to bottom, because it'll be a center core in here coming up into the bottle, which is going to be the opposite pole, dipole here. You're going to have two plates down there and a dielectric, a dipole there. And now you're going to have the ground reacting magnetically to the system. Now, what we do with the magnetically is up to how we start going back out to the coils, the field coils, and what happens to the coils that are wrapped around the wheel. Now, this is another tricky part here, because I believe it's me charging them with a low, tiny voltage, but I believe it's the capacitance that's each one of these pipes has two bottles. So a resistance built in and a capacitance. And the capacitance are basically oscillating out of phase with each other. And what they're doing is they're going to be supplying the power to the coils and the magnets to make the magnets stronger, because now you have energy coming from the earth. So what's going on with the two dielectric plates, dielectric plate and two dielectric plates and four conductor plates, is you're going to have a oscillation going on by themselves like a dishwasher turned sideways. And then you're going to have the same thing going on in the pipe. But the pipe is the electromagnetic from the wheel and the circuitry. In the ground is electrostatic, which is what's making the rest of the ground, like the clouds does, react. So to get energy from the ground, you got to pull it electrostatically. And that's how you're going to get it. And basically your currents are based on the back EMF that we're going to create, because the back EMF is your current. And it's also your electromagnetic field, which is your bounce back, like a spring. So, guys, Happy New Year. A lot more to cover. I can stay another hour on this phone, because I don't even cover half of how you continue from here. I got it all, somewhat figured it out. It's coming together smooth. I'm blown away how when I get this other PMH on this side, that when you turn this wheel, it should be reacting to both of these PMHs, and I predict it to be turning like this on its own, all by itself. Yes, he does, Tommy. Crescents. And that's it. And, the crescent, here's the C. That's your crescent right there. It's amazing. I'm just blown away. This is coming together, the best of the best of the best. I got all the poles written out. Everything's balanced. I got 24 magnets all the way around. I took off the keeper bars here. I want no magnetic, nothing going to this pipe. This pipe is basically a Saturable reactor. Now the Saturable reactor will be reacting on putting AC. We'll have AC being the wheel, and basically putting a small DC into the Saturable reactor, and we'll be able to control the AC's current. And that's how we're going to approach this whole thing. You guys, let's get one more light. That was some good ass damn light right here. Oh, even better, you can take off. I didn't even tell you guys, but Tommy, check this out. I got my full wave bridge rectifier, and I'm coming off the DC side, right? The positive and negative. And I have, no matter how many times you connect off of that DC, you can just branch out. Like, for instance, here I am. I got two negatives coming off, and I've got one going here, and one's going to this big capacitor. Same thing with the positive. I got one going to there. All right. And then we got one. No, not that one. Where's that other positive? Here it is. We'll go to here. Now, everybody, who were like anti-ed, were thinking that this was like a generator for electric. You know what I mean? Look at that. They're both bright. Both capacitors are storing. There's so much energy running off of here. You can't count on one PMH. I mean, let me get a couple good charts. Think about this. The faster I go, the higher the voltage, right? The faster I go, the higher the voltage. That thing's spinning good. I got some more straightening out, but I can't wait to get this thing cemented. That'll add some more weight, more inertia. Look how bright these things are. Crazy. So we could just stop the wheel right now. You can see the wheel. It's just like turning pretty good. That's a lot of weight. Now we'll go ahead and we'll take that one. We got this one. And basically just take a walk with them. And we stored electric here. We'll go in the dark. And we got both. Trying to get them both facing you. I got both lights, LED, stored power from the wheel turning, sitting in a capacitor. So we divided them, we shifted them, and then we separated the existing. And here we are, stored. Saved power. It's not about the wheel being a power generator, because that's not it. It's more about taking the energy, the magnetic flow, the magnetic saturation of the iron, and how it becomes filled, saturated, and it needs to release itself. So you need to be able to release that iron. Now remember that iron. It's got an enormous amount of storage. Its saturation is enormous on how many ions it takes on. Enormous. And when you release that all at once, it's enormous. That back EMF creates a magnetic field. That back EMF creates the current that takes the angle of that electricity and turns it to where it goes in down the wire. This is exciting stuff. Hope you can see I had the LEDs are still lit. I was moving them. Stored energy. No big deal, but it is how we're doing it, and it is how the experiments are coming, and it is how the wheel's progressing, and how I'm suddenly more passionate about this wheel. It has its ebbs and flows, but right now, this is exciting. I'm not all over my workshop beating it down and doing Tesla and doing it. I'm focused on Ed. And I believe there's the inside, the nuclei. You got to look at it as an atom. You got to look at, you need resistance. And that's this magnetic field in here. Think about that. Every time this goes by, it's like a heart. It's beating out, magnetic field, bam, collapsing. And it's swapping AC. That son of a bitch is swapping AC. It's a beautiful thing. Beautiful, beautiful thing. So if you guys just came into the video, go back and watch. I go through the whole process about the PMH, about the whole, how I even got here, how this all comes together. And I hope you enjoyed. Stay tuned because this is even getting better. I'm excited. Happy New Year, everybody.